Recently, Professor Sasaki's group in Tohoku University applied such a synthetic method using alkyl coupling reaction. First, they hydrolyze this olefin with 9 ppm to give this compound in almost quantitatively with high isomeric field, without any isolation and purification of this compound. That is just one pot reaction. Just they try the reaction of this compound with such a alkane triplate in the presence of pyruvic catalyst and base. Then they obtain this cross-coupled product. Next, they hydrolyze this olefin, followed by the oxidation, alkaline hydrogen peroxide oxidation. They can obtain this ketone. Finally, acetal formation of this compound to give this expected polycyclic ether structure, this type of compound. This one cyclic ether, this one is cyclic ether, this one is cyclic ether. This is very interesting synthetic method. Next slide, please. By using this reaction, Sasaki's group synthesized such a very complicated natural product very readily. So that is a very nice synthetic method for this type of structure. Next slide, please. Next, I'd like to tell you the aromatic cross-coupling reaction. We tried such a reaction. First, we used benzene boronic acid and many kind of the phenyl halide in the presence of tetracrystallyl phosphine version and the aqueous sodium carbonate, benzene solution at the temperature. Then we found expected cross-coupled product. By this reaction, we can synthesize biphenyl compound. Biphenyl compound is very, very important compound in industry, as I told you later. For the synthesis of biphenyl compound, next slide please. You may know that we can use Ullmann reaction. Many people know the Ullmann reaction is the only one synthetic method of aromatic biphenyl ERE type of compound. That is only one synthetic method. In the Ullmann reaction, we carried out reaction of aromatic halide with copper powder at relatively high temperature, usually more than 200 degrees, sometimes more than 220 degrees. So high temperature in the organic reaction. We never tried such a drastic high temperature in organic reaction. But in the Ullmann reaction, we need such a drastic high temperature. And additionally, in the Ullmann reaction, we can have one of the disadvantages. That is, by Ullmann reaction, we can synthesize symmetric biphenyl compound, this type of compound, this type of compound can be really prepared, but we cannot synthesize such an unsymmetric biphenyl compound by Ullmann reaction, because if we try the Ullmann reaction of a mixture of two aromatic halide, we may obtain 3 mixture of biphenyl compound. This compound, this compound, this compound mixture. We never obtain this product. However, when we use our coupling reaction, we can synthesize, of course, symmetric biphenyl compound. Similarly, we can really synthesize unsymmetric biphenyl compound. Consequently, this synthetic method of biphenyl ERE compound were used in many chemists. For example, next slide please. For example, these chemists apply such a reaction for the synthesis of their target product. They first try the coupling reaction of this compound and this. In this compound, we get the bromine and iodine. So both iodine and bromine react with this boron group. However, when we try this reaction at room temperature, only iodine group react with boronic acid to give this compound. this iodine, bromine group look reactive under this condition. Without any isolation or purification of this compound, they added second organoborane compound, this compound. At this second step, we don't need any addition of pyridine pentachite base. That is one pot of reaction. So we can only use in the same reaction vessel, we can only add a second this organoborane compound. Different as the second step is reaction temperature. In this step, we carried out this reaction at the room temperature. But here, they carried out this reaction, second step, at 50 degrees. Next, coupling occurs this position with this boric acid to this compound. Followed by reaction, they obtain their target product very nicely. Next slide, please. And also, such a coupling reaction can be used for the synthesis of polymeric compound. For example, this compound. In this compound, in the same bond structure, bromine and boric acid. Under this condition, our coupling occurs to be expected polymer of this compound. That determines this compound has a helical structure because of steric hindrance. Therefore, I was surprised when I read this paper, we can synthesize such a sterically very hindered helical structure compound very deeply by this cross coupling. Anyway, we can synthesize polymeric compound. Next slide, please. Such a coupling reaction can be used in industry, like in the pharmaceutical industry and the agrochemical industry and other industry also. I tell you it is proper. This is losartan. Losartan made by American milk. Milk we have two milk. One is American milk, another is German milk. But anyway, American milk, they put this synthesis of this losartan. Losartan is very useful. They are anti-hypertensive. The blood pressure go down. That is very important. For example, my case, I tell you a little bit about private history. Last, I think, 2 years ago, I think, I'm very healthy. I don't have any problem. But every year, I ask the medical doctor my body check. So he said, you are very nice, but your blood pressure is little bit high, not so seriously high. But therefore, I agree to eat such a anti-hypertensive drug. So my doctor gave me the prescription card, so I indicate such a card at the pharmacy. Of course, as you know, pharmacists know very, very strong, usually strong with the organic chemistry. So such a pharmacist said, Professor Suzuki, this is one of such anti-hypertensive made by the American milk. That in Japan, when you say a company, they sell us. So this product made by your cross-coupling reaction. So this is the first time I know actually our reaction can be used in industry. But anyway, that is this. In Japan, losartan is the international chemical name. In Japan, the drug is called neurotan. But anyway, the American milk company synthesized this compound by cross-coupling reaction of this phenylboric acid and phenylbromide under this condition. Not only the American milk, next slide please. Similarly, other pharmaceutical companies, for example, the Novartis company in Switzerland, they also produce this compound as anti-hypertensive. This is named as valsartan. they tried to produce this compound by our coupling reaction between this aromatic group and this aromatic group at this lead protection. They produce this compound. One day, when I was in Tokyo, one of the people of Novartis visited me in the hotel. He told me Novartis company produced this compound as antihypertensive. This is so many people use. In Japan, 3.5 million Japanese people use this compound. In the whole world, 22 million people use this compound. Next slide, please. Not only such a Novartis and the American, other companies use. This is American company, I told you before. This is Behringer Ingelheim in Germany, also produce this compound. And also this is Sanofi Aventis in France. This is Takeda pharmaceutical industry in Japan produce this kind of compounds as antihypertensive drugs. All of the reaction use our coupling reaction, this part, and this part, and this part. Next slide, please.